Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at enthalpy and enthalpy change. We're going to talk about what enthalpy actually is, why and how enthalpy changes during a reaction, and look at the units for such changes and where they come from. Standard enthalpies and enthalpy changes, including Hess's law, have been covered in separate videos. Check the links in the description below. Before we talk in detail about enthalpy, there are a few essential ideas you need to be comfortable with. Energy is a property that a substance can have that allows it to do work. Work here means anything that causes a change in the universe. Whether it is a particle moving around or two substances reacting together, the universe is being changed just a tiny bit in some way, and work is being done. Energy is measured in a unit called a joule, and to make things easier with larger values, is often given as kilojoules. 1,000 joules equals 1 kilojoule. Generally, things that have low amounts of energy are less able to do work and cause change. Because of this, they are considered more stable. Things that have more energy are more able to do work and cause a change, and as a result are considered less stable. The heat content or thermal energy of a system is how much energy there is inside it. When heat flows into a system, its heat content will increase, and when heat flows out of a system, its heat content will decrease. All particles in the universe have some heat content, even if it's very small. Temperature is a measure of how hot or cold something is. This is based on the average kinetic energy of the particles within it. The higher the temperature, the hotter an object is, and the more the particles in it are vibrating. Temperature in chemistry is often measured in Kelvin, as this scale directly links the value of temperature to the energy content of a substance, meaning at 0 Kelvin, a substance has 0 joules of heat energy in it. Temperature changes can be more conveniently measured using degrees Celsius, as a change in 1 degree Celsius is the same as a change in 1 Kelvin. But be careful, 1 Kelvin is not the same as 1 degree Celsius. When measuring amounts in chemistry, the standard unit used is the mole. 1 mole equals 6.022 times 10 to the power 23, also referred to as Avogadro's constant. A molar quantity refers to a value or measurement based on a mole's worth of a substance or particle. For example, 10 joules per mole is no different to 5 joules per half mole, or 20 joules per 2 moles. It is just often easier in chemistry to work with molar values to enable comparisons to be made. Recap done? Let's go! All molecules and substances have energy stored inside them, sometimes referred to as chemical potential energy. This energy is stored in the form of bonds between atoms within molecules and even inside the atoms themselves. At the same temperature, different substances have different amounts of energy locked up inside them. The only way energy can flow in or out of a substance, though, is in the form of heat. This effectively means all molecules and substances have thermal energy stored up inside them, as when some of their potential energy is released, it flows out of the molecule in the form of heat. This storage of thermal energy or heat content inside a substance is called enthalpy and has the units kilojoules per mole. It is represented with a capital H. The bigger the value of enthalpy, the more thermal energy there is stored up inside a particular substance or system. It is practically impossible to know the exact enthalpy of a substance, as there are many things to consider. Just thinking about the energy concerning an atom's nucleus is enough to make your head hurt. It is possible, however, to measure how the enthalpy of a substance changes when it reacts. This means in chemistry, we work with enthalpy changes rather than total enthalpy values. Enthalpy changes are shown with a delta symbol, meaning change, and a capital H, enthalpy, and we often refer to them simply as delta H. There are only 2 ways the enthalpies of reacting particles can change as they form new products: increase or decrease. We can show these enthalpy changes using reaction profile or energy level diagrams, with enthalpy, or energy, shown on a y-axis increasing upwards. If their enthalpy increases, more energy is being stored up and locked away inside the reacting particles, and the energy contained in the products is higher than in the reactants. This kind of reaction is called an endothermic reaction, and as the enthalpy content of the reacting particles has increased and gone up, it has a positive value. If the enthalpy content decreases, a little bit of energy has been released from inside the reacting particles, and that means there is now less energy stored up in the products compared to in the reactants. This kind of reaction is called an exothermic reaction, and as the enthalpy content of the particles has decreased and gone down, it has a negative value. The energy that flows in or out of reacting molecules will always be heat. This means particles surrounding reacting molecules will exchange thermal energy with them during a reaction. The temperature change of surrounding particles is based on the change in enthalpy of the reacting particles. For exothermic reactions, the heat energy lost by the reacting particles will go to the surrounding molecules and make them vibrate more, increasing their temperature. This is why temperature of surroundings increases for exothermic reactions. For endothermic reactions, heat energy has been taken from the surroundings and gets locked up inside the reacting particles. This means the surrounding particles have less energy to vibrate and move, decreasing their temperature. This is why the temperature of surroundings decreases for endothermic reactions. We can actually use the change in temperature of a reaction's surroundings to find the enthalpy change of a reaction. This is called calorimetry and has been covered in a separate video. Check the links in the description below. We have to be a little bit careful though, as there is another factor that can cause the temperature of a reaction's surroundings to change: the pressure of the system. If the pressure of a reacting system increases, the temperature of the particles inside it will also increase. Equally, if the pressure decreases, the temperature of the particles will decrease. As many reactions involve the production or use of gas molecules, pressure changes are common in reactions. This means that the temperature change of the surroundings of a reaction may be based on the change in enthalpy of the reaction, as well as the change in pressure of the whole system. To get around this, enthalpy changes must always be measured at a constant pressure to ensure changes in temperature of a system's surroundings are based only on the flow of heat energy in or out of the reacting molecules, enthalpy change, and aren't being affected by changes in pressure. This is why enthalpy change is referred to as heat energy change measured under conditions of constant pressure. So, to summarize, all substances have potential energy stored up inside them. Different types of molecules and particles have different amounts of stored energy. This stored energy can only ever leave the substance as heat, meaning it is effectively a thermal energy store. The heat content or thermal energy store of a substance or system is called enthalpy and is measured with the units kilojoules per mole, and is represented with a capital letter H. It is never possible to know the exact enthalpies of substances. Instead, we measure changes in enthalpy when they react or undergo any kind of change. Enthalpy change is defined as heat energy change, represented with the symbol delta H. For chemistry, units are kilojoules per mole, and measurements must be made at constant pressure. During a reaction, heat energy can be exchanged between reacting particles and their surroundings. The amount of heat energy transferred is the same as the change in enthalpy that is occurring. This can easily be observed by looking at how the temperature of a reaction's surroundings changes during a reaction. Changes in pressure and the number of particles reacting has a direct impact on the measured temperature change of the surroundings. To overcome this, we ensure enthalpy is measured at a constant pressure and is given in the units of kilojoules per mole. Energy can be released by reacting particles, making products lower energy and more stable, but increasing the heat content and temperature of their surroundings. These reactions are called exothermic reactions and have a negative enthalpy change. Energy can also be absorbed by reacting particles, making products higher energy and less stable, but decreasing the heat content and temperature of their surroundings. These reactions are called endothermic reactions and have a positive enthalpy change. I hope you found this video useful. Please check out other relevant videos given in the links in the description below and visit chemistrystudent.com for free notes and revision materials.